Welcome back to part 2 of Mastercam 2022 Unified Multi-Axis Toolpath webinar. In the previous video, we were talking about how Unified can be replicated on classic toolpaths such as Morph, for example. Now, we can still use Unified on a different variety of examples. For example, the Project toolpath. It's by no means a replacement for the multi-axis classic toolpaths, but it's to show you how Unified can easily be utilized for that scenario. Okay, so I'm going to jump to this project curve and drop my arrow down and jump into the Unified. So to start off, I'm going to select a cutter, and for my cut patterns, I'm going to select the curve mode. For the curve mode, we can very easily go and select a window selection over the logo and give it a start point to where we want to start this. If I say OK to my selection, I need to stipulate a machining region to project the curves to, or a surface to project it to. I'm going to select the back face and say OK. Now, in our strategy, very quickly, we could jump into a project mode. So projecting, and we would probably want to give it a slightly different projection distance since the logo is offset from that surface, and then work your normal routine from a top-down approach as we normally do. So if we jump into tool axis control, we can use a surface with a tilt. We can give it an angle, but I'm going to touch on limits for this example. And if we jump into the limits, you can see in the limits we've got different plane limits that we can focus on. Now, if we look at the part, our part on the projection will be coming from left to right, as seen over here. Our axis is in a ZY approach, so those limits I'm going to focus on is the YZ limit. Now we've got our minimum and maximum, so to give it a angle, I would say 90, probably somewhere around 150 degrees from right to left, and then focus on our collision. We actually can turn the collision off for this instance. We're just doing project sketching, although we can focus on the actual retract itself. So linking parameters you can adjust accordingly. So we will give it a retract to feed and a retract to rapid. Okay, you don't have to worry about your leading lead outs. We can actually use the small gaps as a value of the cutter, a value rather than a percentage of the cutter. And in our plane modes, I'm just going to lift it up slightly like we did in previous examples, and then you can pretty much go from there. So if I say OK, very quickly we get a toolpath that is identical to our classic project toolpath. Very simple, with a couple of settings, we've created the exact same toolpath. Now, like I said before, this is not by any means a replacement for any of our classic toolpaths. It's just to show you how easy it is to get the same results using Unified. With Unified, you can chop and change your strategies, making life just a lot more easier. So, without further ado, I'm going to jump into a slightly different example. So for that, I need to go into my levels. I'm going to turn on level 2 and just turn off the rest of the things. And just turn off that toolpath so we don't see that. Now, we've got a tube sort of port type example here with a fixture, very nicely laid out. And if we jump to our long toolpath, that is a classic long toolpath for this example. Really nice toolpath in the classic mode. So for this example, I'm going to show you the power of Unified and how this plays a role in this particular example. So for that, I'm going to jump into my levels and turn on the workables that we've prepared for the model. We can turn off that toolpath for this example, and we've got our arrow in the right place, and we jump into Unified. We can we can probably jump into a more lollipop cutter. Right, now the lollipop cutter coming from inside approach, and then we would strategically need to come through our parameter settings and ensure that we set everything accordingly. So if we jump into cut patterns, it is a curve related scenario, as I want to use this green curve over here as my guide curve, my drive curve, whatever you want to call it. So I select that curve and I say OK. Now, keeping in mind we would need to have a particular surface involved with that. Right? So if I come into this selection, that was for my curve, my physical machining geometry would be stipulated with this machining surfaces here. Selected that, say OK. Then we would slowly work down the workflow. For this example, I'm going to turn off, I'm going to keep my tool axis control. I need to definitely start looking at focusing this on a more internal approach, so we're going to have to be strategic about this. I'm going to say fix angle to axis, but I'm going to slightly change this up because we're not really coming from the Z. If we have a look at our part, you'll notice we've got our x-axis lying in that direction there. So I'm going to use this as a x-axis approach, and with that I'm going to jump into collision. Actually, we've got limits on here as well. So what I can do with the limits is, instead of using my XY limits, I can actually use a conical limit. So keep my tool within inside a region of there. Same thing applies. We're going to use a minimum maximum, but definitely not 180. We'll reduce this slightly, give it maybe 30 degrees, but also keep it within the x-axis approach. Collision control, we can turn it on should we see fit, and we can say we want to avoid all these guys, and we want to tilt tool automatic and leave it on the machining regions, because that's actually the avoidance that we have right there. Lastly, we're going to come to linking. This is going to change slightly as well. So as before, we could use a lead in, lead out approach. I want to give it a more arc scenario again. So let's give it a use lead in, lead out. These are going to be slightly different, and so is the last exit. The last exit, we actually have a retract to clearance through the tube center. If I select that, you can see on the example in the image, nice little clearance through there. We can give it a blend spline and wrap it to clearance on our large gaps. So we've got all that set and everything's good. The only difference here in this plane is we're still coming from the Z. We want to actually come from the X. We can actually reduce this by quite a lot, since our axis is bang on the center of that. And it's starting to look a little bit tidier. We come to our arc entry. I want a tangential arc like I had before. We can reduce this by 90, copy that over. So I've got my lead in, lead out, and my spiral approach. Now, the one thing I just want to confirm is whether we had a one-way or spiral, but I prefer to be on a one-way scenario rather than a zigzag, giving it a one-way cut, more controlled, and so forth. And everything else would be set accordingly. So with that being said, I'm going to say, okay, now, bear with us on this example. Mastercam 2022 has automatic calculation, a regeneration of the toolpath, and you can see very quickly I've made a fatal mistake. Now, this is my personal example of why I believe the unified toolpath is a complete game changer for the multi-axis module. Now, I clearly made a mistake. Now, in previous versions of Mastercam, if you did such an instance like this, you'd have to completely start again. If anything, your PC is going to hang and it's going to be a message somewhere. You've made a fatal error in what you've done here. Not with Unified. If I jump into my Unified here, I specifically did this for a reason. I forgot to change my style to a perpendicular style. very quickly I come into the unified cut pattern, I change it to perpendicular and select OK, automatically recalculates my toolpath. And what I end up having is a perfect example of the long curve as in the example seen below. Now, this for me is a complete game changer altogether. It's completely night and day. So this is a good example of what I wanted to show you, and this is an example of why I believe the unified plays a very good role. And we have definitely got a lot more examples that we can show you, but this is definitely, without a shadow of a doubt, a complete game changer for the multi-axis module. By doing such unique changes in the style, is able to give us a better understanding of what is going to be the best suited scenario for any particular job. So I'm going to leave it at that, and if you have any questions based on my webinars, you're more than welcome to contact me by my email. I'll be sending these links out, but thanks you very much for joining us on this Multi-Axis Unified webinar, and hope to see you guys soon, and stay tuned for more videos to come. Take care. Goodbye.